Okay, real talk for a second. Who hasn't freaked out over a breakout right before something important? You know what I mean? Like, picture this. What if acne treatments were actually, like, way more effective, and they didn't contribute to that whole scary antibiotic resistance thing? Well, get this. That's exactly what we're diving into today. We're looking at some seriously cool research. It's coming straight out of Wroclaw Medical University, where these researchers, Agnieszka, Kostrzębska, and Gabriela Szczepaniak, they've been like whipping up these new anti-acne formulations, and they just published their findings. It's in this journal called Polymers in Medicine. And let me tell you, it's got us all kinds of excited. So what's all the hype about? What makes these formulations different? Well, let's find out from our expert. What's got you buzzing about this research?
For me, it's how it tackles this problem that, well, it's so common but often misunderstood, like acne vulgaris, the most common type, right? It affects a whopping 85% of adolescents and young adults. And it's not just a cosmetic thing.
Mm.
Acne can really mess with someone's mental health and self-esteem.
Oh, totally. We've all been there, and it's rough. And like this research points out, the current topical treatments, they kind of have their limits. So tell me, what's the science behind these new formulations? What sets them apart?
To really get it, we got to understand the problem at its core, right? Acne is this like perfect storm of three things. You've got the overgrowth of Cutibacterium, acnes bacteria. Then there's excess sebum production, and of course, all that leads to inflammation. So these new formulations, they're designed to tackle all three of these troublemakers, like head on.
Okay, I'm hooked. So let's break down these acne-fighting ingredients. The research highlights tetracycline, azelaic acid, and this thing I'm not as familiar with called azelaglycine. Now, tetracycline's an antibiotic, right? Haven't we been using that forever to fight acne?
Yep, spot on. Tetracycline has been a staple in acne treatment for ages. But there's a twist, right? It's super sensitive to pH levels. If the pH isn't perfectly balanced, tetracycline can degrade and become less effective.
And here's where it gets really interesting. The study mentions that tetracycline doesn't just, like, fade away quietly. It actually changes color as it degrades.
You got it. It can go from this light yellow to brown, maroon, or even black. Not exactly the look you're going for in your skincare routine.
No kidding. Can you imagine? So keeping tetracycline stable is, like, mission critical for these formulations to actually work. And that's where this mysterious azelaglycine comes in.
Exactly. Think of azelaglycine as azelaic acids, like cooler, more reliable sibling. Azelaic acid itself is great for acne, but it can be a bit, well, unpredictable. But azelaglycine, total team player.
So it works well with tetracycline.
Got it. It actually helps stabilize it. Unlike azelaic acid, azelaglycine keeps that pH nice and near neutral, which is exactly what tetracycline needs to do its job.
So we've got this dynamic duo, right?
Yeah.
But how do they actually get to the skin and work their magic? The study mentions hydrogels. What are those all about?
Okay, so hydrogels are basically these water-based gels. They can hold and release active ingredients. Think of them like these tiny little delivery systems. And here's where azelaglycine really shines. It helps create hydrogels that are more viscous.
Okay, hold up viscosity. Is that just a fancy way of saying how thick or runny something is? Why does that matter for acne treatment?
All right, so picture this. You put water on your skin, right? And then you put honey on your skin. The honey being thicker, it's going to stay put. It sticks better, right? Same thing here. A thicker gel is going to cling to your skin better, and it'll release those active ingredients more evenly over time. That's what makes these azelaglycine-based hydrogels so special.
Okay, so azelaglycine isn't just a stabilizer. It's like the key to making the whole delivery system work. But wait, there's more, right? The research hinted that azelaglycine does even more, like beyond just stabilizing things.
You caught that, huh? Impressive. Yeah, azelaglycine is a real multitasker. It can help lighten those annoying dark spots acne leaves behind. Hyperpigmentation. It reduces redness. And it even helps regulate sebum production, like preventing future breakouts. It's like hitting multiple acne targets with one ingredient.
Now that's what I call a skincare superhero. This azelaglycine is sounding like a game changer.
It's definitely showing a lot of promise, but of course there are still some hurdles, right? One of the big ones is antibiotic resistance. It's something researchers are really focusing on. They're looking for ways to make the treatment as effective as possible, but without increasing that risk of resistance.
That's super important, and we'll definitely come back to that. But before we move on, there's one more thing I'm curious about. The study mentions another ingredient, AMPD. What does that do in this acne-fighting cocktail?
Okay, so AMPD, full name, 2-amino, 2-methyl-1-48 propanediol. It might sound like a mouthful, but it's crucial. It works with azelaglycine to regulate the pH of the formulation. But here's the cool part. AMPD is like a built-in cleanser. It helps clear out those hair follicles and stops them from getting clogged up with sebum in the first place.
So it's like a two-for-one deal, regulating pH and keeping those pores clean. That's some seriously smart formulation design. But with all these benefits in one treatment, could these formulations be used for more than just acne?
That's a great question, and it's something researchers are definitely looking into. These formulations have potential for treating all sorts of skin conditions, like rosacea, psoriasis, even some skin infections. The possibilities are pretty amazing.
Wow, that's incredible. Sounds like these formulations could change how we think about skincare altogether. But let's not get ahead of ourselves. This research is still pretty new. We got to be careful and wait for more testing and clinical trials before we get too excited.
Right. Absolutely. We got to be thorough. Make sure these formulations are both effective and safe in the long run. But the initial findings are really promising. It gives us a lot to be optimistic about for the future of acne treatment.
So we've got this powerful combo of ingredients, a super smart delivery system, and a ton of potential. But how did these researchers actually put it all together? What did their experiments look like? That's what we'll be diving into next. Stay tuned.
All right, so before we jump into the experiments themselves, we got to understand the bigger picture of acne treatment, right? For forever, the go-to solution has been antibiotics. Usually you take them orally. And while they work, this approach has kind of led to a big worry. It's a growing concern in the medical world, actually. Antibiotic resistance.
Yeah, antibiotic resistance is a huge problem. We keep seeing more and more bacteria becoming resistant to the drugs we use. It's getting harder to treat infections. It's kind of scary when you think about it.
It really is. And this research, it offers a possible solution, specifically for acne treatment.
By using this super clever combo of ingredients that all work together, kind of like a tag team.
Exactly. Kostrzębska and Szczepaniak, the researchers, they emphasize that combining tetracycline with either azelaic acid or azelaglycine, it could boost how well the treatment works and lower the risk of that antibiotic resistance happening. It's like hitting acne with a 1-2 punch, targeting it from different angles.
So instead of just relying on an antibiotic to wipe out the bacteria, these formulations use other ingredients to tackle the inflammation and the excess sebum production, which are also big players in acne. It's a much more holistic approach, right?
Exactly. It's about getting to the root of the problem, not just covering up the symptoms. And the study really highlights how important the delivery system is for getting these ingredients where they need to go. They talk a lot about hydrogels and the viscosity.
Right. We talked about viscosity before,
Right.
and how a thicker gel can stick to the skin better and release the ingredients more evenly. But what did the researchers actually find in their experiments?
Well, they found that azelaglycine was the key. It was essential for creating these hydrogels with that perfect viscosity. Remember that honey analogy? Well, the formulations with azelaglycine, they reached an average viscosity of about 10,500 CP, which is honey thick. So they'll stay right where you put them and deliver the medicine effectively.
So azelaglycine is the magic ingredient. It makes the whole delivery system run smoothly. It's amazing how they thought of everything.
It really is. Now, we've talked a lot about tetracycline and azelaglycine, but what about azelaic acid? Where does it fit in all of this?
Right, azelaic acid. It's been used in acne treatments for a while now, hasn't it?
It has, yeah. And it's got some pretty impressive qualities. It's antibacterial, comedolatic, and keratolytic. Basically, it helps kill bacteria, stop pores from clogging, and removes extra skin cells.
Oh, it's a multitasker, just like azelaglycine. But if they're both so great, why focus on azelaglycine?
Good question. See, as the research points out, azelaic acid has a couple of downsides. It's not as stable as azelaglycine, and it can be harder to work with when you're making these formulations. Plus, it doesn't help make the hydrogel thicker the same way azelaglycine does.
So azelaglycine is kind of like the upgraded version. It has all the good stuff from azelaic acid, plus some bonus features.
You could say that. That's why the researchers see azelaglycine as the better option.
But they did some experiments with formulations that had both azelaic acid and azelaglycine, right? Was that just to compare them?
And that was part of it, yeah. They wanted to see how each ingredient affected the stability of the tetracycline and the overall properties of those hydrogels. And what they found was pretty fascinating. The tetracycline stayed stable for over a month. 35 days to be exact, in most of the formulations, especially the ones with azelaglycine.
That's really impressive. That means these formulations could give people long-lasting relief from acne. No more having to reapply all the time.
Precisely. And don't forget, azelaglycine is bringing its own benefits to the party.
Oh, yeah, right. The hyperpigmentation fighting, redness reducing, sebum regulating benefits. Can't forget about those.
It really is a multifaceted ingredient. But, one of the things that gets me really excited about this research is its potential for things beyond just acne. The study mentions other skin conditions like rosacea, psoriasis, even some infections.
Yeah, we touched on that earlier. But tell me more. How could they adapt these formulations to treat those other conditions?
Okay, so imagine this. Azelaglycine, with its anti-inflammatory and antimicrobial powers, it could be a really valuable tool for treating all sorts of skin problems. And tetracycline, with its broad-spectrum antibacterial activity, it could be really effective in fighting different infections.
So even though this research focused on acne, the implications are much bigger. It's like they've discovered this platform that can be customized to treat a whole range of skin concerns. It's groundbreaking stuff.
It really is. It shows how important scientific exploration and innovation are. You never know where a simple question might lead you.
Like that saying, curiosity is the engine of achievement. But let's be real for a second. We've talked about all these amazing possibilities, but these formulations are still in the research phase, right? What's the next step? What needs to happen before these treatments can actually help people?
You're absolutely right. We need more research, specifically large-scale clinical trials. Those trials will help us figure out the long-term effectiveness and safety of these formulations and make sure they really work and are well tolerated by a lot of different people.
It's all about making sure everything is safe and effective before these treatments are available to everyone. But it sounds like researchers are on the right track, wouldn't you say?
Definitely. This research really shows the power of collaboration and the drive to find better solutions. It gives us a glimpse into a future where acne and other skin conditions can be treated more effectively and with fewer side effects.
It's a future I'm definitely looking forward to. But before we wrap up, I wanted to go back to the experiments themselves. What were some of the key findings that really stood out to you? What were those aha moments in the research? All right, so we're back. And in this final part, we're going to zoom in on the experiments themselves. We'll see what Kostrzębska and Szczepaniak actually found. Get ready for some science, but don't worry, we'll keep it clear and interesting.
One thing that really struck me about their study was how thorough they were. They didn't just throw ingredients together randomly. They designed and tested all these different formulations. They were really careful about things like pH levels and the viscosity and how stable the tetracycline was over time.
It sounds like they were on a mission to find that perfect acne-fighting formula. What were some of the things they were looking for?
Well, one of their key findings was how important azelaglycine is for keeping that tetracycline stable. We've talked about this a bit already, but it's worth repeating. Tetracycline is powerful, but it can be finicky. If the pH isn't just right, it breaks down.
Yeah.
And then it doesn't work as well.
Right. It's like it needs the perfect environment to do its thing. And the azelaglycine is there, making sure everything's good. But did the researchers actually see a difference in stability when they added the azelaglycine?
Oh, yeah, for sure. Their experiments showed that the formulations with azelaglycine, they had way less tetracycline degradation compared to the ones using just azelaic acid.
So that's a big deal, right? It means these formulations could last longer on the shelf, and they'd stay effective for longer.
Exactly. And that's not all. They also looked at how these ingredients affected the hydrogels themselves, specifically their viscosity.
We talked about that before, how viscosity affects how well the gel sticks to your skin and how it releases the ingredients over time. Did they find anything interesting there?
Great, they did. They found that adding azelaglycine made the hydrogels much more viscous compared to the ones with azelaic acid. Remember we said honey has a viscosity of around 10,000 CP? Well, the azelaglycine formulations were even thicker than that, around 10,500 CP on average.
Wow, so azelaglycine isn't just a stabilizer. It's like a thickening agent, too. It makes this really robust gel.
It does, and that's what makes this research so cool. They didn't just find effective ingredients, they figured out how to deliver them in the best way possible.
It's really impressive how much thought they put into every detail. But let's be practical for a minute. These formulations sound amazing, but they're still in the research phase. What happens next? What needs to happen before these treatments can actually help people?
Well, the researchers say we need more clinical trials, larger ones with more people with different skin types and different types of acne. It's all about making sure these formulations are safe and effective in the long run.
Of course, safety and effectiveness are super important. But let's say those trials go well and these formulations get approved. What then? What does the future of acne treatment look like?
Well, one really exciting possibility is personalized treatment. Imagine a future where dermatologists could analyze your skin microbiome and create a treatment specifically for you.
That sounds like something out of a sci-fi movie. How would that even work?
It's not as crazy as it sounds. We're learning more and more about how the skin microbiome affects acne. So by figuring out which bacteria are on your skin, dermatologists could adjust these formulations, add specific ingredients that would work best for you.
So it's like personalized medicine, but for acne. No more one-size-fits-all solutions.
Exactly. And these new formulations with azelaglycine and tetracycline, they're perfect for that kind of personalized approach. They're like a platform that you can adapt and fine-tune.
That's incredible. This research could completely change how we think about acne treatment. But for now, we'll have to wait and see